welcome to this fourth video of Mathematics Part 1, lesson number 4, Ratio and Proportion of Standard 9. In previous videos, we have seen about what is ratio and its properties, and we have seen the sums based on it. Now in this video, let's see about the word proportion. What is the meaning of the word proportion, and in how different ways we can use it, the word proportion. So let's start about proportion. So when the concept of ratio of two numbers can be extended to the three or more numbers, it's called proportion. So this is the one way of using the word proportion. Means in ratio generally we compare the two quantities of same kind, of same unit, and that comparison by division we call it as ratio. Okay, we have seen in this previous video. But instead of now two numbers or two quantities, if two numbers, if we are using more than two, that is three or more, then in that case we call it, it is in proportion. What is the example of it? Let's take the example to understand this. So for example, if for making rava laddus, okay, rava laddus is the sweet thing, sweet made from the rava. Rava is made from wheat. Okay, so if making laddu, say Vimal is a girl who takes 1 bowl of ghee, 3 bowls of rava, the words can be called as suji also, and 2 bowls of sugar. Okay, then the proportion of ghee, rava and sugar is, say what is the bowl? 1 bowl, then 3 bowls and 2 bowls. So 1:2, 3:2. So this is the here we do not call it ratio, here we call it as proportion. Actually, so here little bit we are using the word proportion in replacement of ratio. Okay, so either saying ratio, or we can say the better word is proportion here, because there are more than two quantities. So in this proportion she is taking that ingredients and making that laddus. Okay, if she wants to make some more laddus, and if she takes say 2 bowls of ghee, then she should take, if she is multiplying here by 2, here also she has to multiply by 2. For 2 bowls of ghee, she has to take 6 bowls of rava and 4 bowls of sugar. So that will be also in the same proportion, and she can make laddus of the same taste. Okay, so this is the one way of using the word proportion. Okay, what is the another way where we use the word proportion? Okay, let's see the second type. Okay, so for the given 4 numbers, okay, A, B, C, D, suppose these are the 4 numbers, and for these 4 numbers, if the situation is that A is to B is equal to C is to D, what does it mean? That the ratio of these first 2 numbers, if we take, and if we take the ratio of the next 2 numbers, and if these 2 ratios are equal, in that case then we can call that the numbers A, B, C, D are called in proportion. Okay, so this is also another way where we use the word proportion. So where the ratio of 4 numbers taking 2 at the time, it is equal, they are called in proportion. So if A is to B, that is A upon B is equal to C upon D, then what do we get? By cross multiplication we get A into D is equal to B into C. Or in other words, we can say product of the extremes is to, out of these 4 numbers, first and the last called as extremes. So product of these extreme numbers is equal to the product of the mean numbers. These middle 2 numbers are called mean, M-E-A-N, means. So product of extreme is equal to product of means. Means here we will do sums in the next video. So if one out of these 4, suppose we know any 3 numbers, and if you want to find any 4th number in that group, we can find with the using this equation. Means suppose we know first, second and third number. If we want to find the 4th proportion of the 3 numbers, we can use this formula and we can get its value. Or if we do not know, say any one of this, okay, then we can find the remaining the one. So first A is the first proportion, B is the second proportion, C is the third proportion, and D is the fourth proportional. And A and B, as I told you, they are extreme proportion numbers in the proportion, and B and C, the middle, are called mean proportions. Okay. There is one more concept called as continued proportion. We will study about it, but not now. After the practice set 2-3 exercises after this, we are going to study about it as continued proportion. Okay. Now let's go for the another way of the word use proportion. Okay. So when two quantities, say x and y, are related with each other such that change in x causes change in y in one of the following ways. Okay. So basically there are two quantities, they are related to each other such that, so the two quantities can be, if one is say x and the other can be y, and change in first quantity relates changing the another quantity. Now how it gets changes? The changes can be one of the following way. What is the first way? Say if x, what does it mean? I have written in symbol. If x increases, upwards I have showed this arrow, it means if x increases, then y increases. Or if x downward arrow means decreases, then y decreases. Means if there is a increase in x, increase in y. Or if there is a decrease in x, then there is a decrease in y. Then, but one more thing is here, it happens, but their ratio means division, x upon y, remains constant. So both are behaving in the same direction, but their ratio remains constant. In that case, we call it that this two quantities x and y, they are in direct proportion. Okay. So when such relation we find, we have direct proportion. Or what is the other one? In other which way it can be related? That if x increases, then y decreases. So if there is a change, x is going up, then y is going down. Or if x is decreasing, then y is increasing. If the first quantity is decreasing, the second will increase. So we can see the inverse relation. One goes up, second goes down. One first goes down, the other goes up. But their product remains constant. Okay. If in both the cases, whatever may be the cases, if the product remains constant, we call it as inverse proportion. So basically direct and inverse, these are the two types of proportion. Okay. Here the word proportion is also called as or replaced as the word variation. Okay. So this varies, x varies accordingly y, or y varies means changes according to x. For this, let's take one example of both types, so you will come to know how these are changing. Okay, if I take the example of say one car is going certain distance in say kilometer. Okay, and say if it is taken as time, okay, hours. Okay, so if the speed of the car is say 40 kilometer per hour, the car is going for speed of the car is 40 kilometer, then suppose we take this, suppose we are assuming that distance traveled by the car is say x and time taken to travel is say y. If the car is traveling for 1 hour, the distance covered will be 40. If the car is traveling for say 4 hours, so how much distance it will travel? It will travel 160. We can understand that in 1 hour 40 kilometer, then in 4 hours 160 kilometer. And suppose if it is traveling for only 2 hours, then it will travel 80 kilometers. Now you can see that if when x is 40, y is 1. When x is going up, here the x is increased, okay, then y is also increased. So if x increases, then y also increases. Or if x decreases, here the x is decreased, okay, then y is also decreased. Here, but we have to check one thing to declare that these distance and time are in direct proportion. We have to check whether its ratio, that x upon y, is what is its value. So if you take here in this case 40 upon 1, so value is 40. What is the ratio of x upon y in the second case? It is 160 is x upon y is 4. If you divide this 160 by 4, you get it 40. If this third case, if where 80 is your x and y is 2, 80 upon 2 is also 40. Okay. So now not only this increase or decrease this matters. In each case, if this ratio is equal, if it is constant, then we can say that x and y are in direct proportion. Okay. So this is the example of direct proportion. We can have many examples like this. Suppose if we want to distribute some sweets to some children, okay, and if we are going to give say 2 sweets, 2 pedas or 2 laddus for some students, if there are 40 students, then we will require 80 pedas. If there are 60 students, we will require, means suppose your x is number of children, okay, number of students or children, and y is say number of laddus required, okay. Okay, then it can be, so if there are 40 students, we require say 80 laddus. In the other case, if there are 60 children, we require 120 laddus. If there are 10 children, then we will require 20 laddus. So in that case also you can see what is the ratio of x upon y. X upon y, this ratio is what? 40 upon 80, that is 1 upon 2. 60 upon 120, that is also equals to 1 upon 2. And 10 upon 20, this is also equals to 1 upon 2. So where the ratio is constant, we can say we have direct proportion or direct variation in this two quantities. Okay, so this was the direct proportion. Now let's come to the example of inverse proportion. Okay, now suppose let's take the example of saying the car. Now if the car has to travel say distance of 240 kilometers, okay, say from A to B, say from A city to B city, if the distance is 240 kilometers, okay. Now what we should be at what speed and what time it will take. Speed is kilometer in hour and the time is calculated in say hour. Suppose this is your x and this is your y. Okay. Suppose the car is traveling by 40 kilometers per hour, then how much time will be required to travel the distance of 240? We know that time is calculated as distance upon speed. Okay. So if you divide this 240 by speed 40, the answer is going to be 6 hours. Okay. So here it will take 6 hours. But if the speed is increased, if it is 80 hours, then what will happen? So how much time it will be required? So in that case 240 distance should be divided by 80 speed. In that case it is 3 hours. So the car will take 3 hours. Okay. And if the speed is 60, then what will happen? And the distance 240 should be divided by 60 kilometers per hour speed, and in that case you can get it 4. Okay, so 4 hours. So here what do you observe? Here when the speed is increased from 40 to 80, so here it is an increase. And what happened to time? Why? The time has gone down from 6 to 3. So when the speed is increased, x is increased, y is decreased. X is increased, y is decreased. And when 80 to 60, you can see that there is a decrease in the speed. Then from 3 hours to 4 hours it has been taken. So when x is decreased, the y is increased. X is decreased and y is increased. But we need to check, of course here it is going to be, we know that speed into time is equal to distance, and in that case the product x into y, which is equal to your this distance, product of this 40 into 6 is equal to 240. Then 80 into 3 is also equals to 240, and 60 into 4, this product is also 240. Basically, we have taken a fixed distance between two cities which is not going to change. So in both all three cases the product is constant. So in that case we can say these two quantities x and y are in inverse proportion. Okay, so if we have any other condition we can find the value of that. Means if suppose if the car has to reach in 2 hours, if the car has to reach in 2 hours from A to B city, then what should be the speed? Okay, so if it is here it is 2, what should be this? We can find values of the, if we know one value of one quantity, then we can find value of the other quantity also. Okay, so from one set of information we can find any one of the variable from the question. Okay, so we can solve the questions based on direct proportion or variation and inverse proportion or inverse variation. So today we have seen different meanings of proportion. Sorry, please bear some sounds in the surroundings. I cannot control that sound, so please bear it. Okay, so we have seen different meanings of proportion. So when the concept of ratio is extended from 2 numbers to 3 or more numbers, we call it proportion. Then when ratios of first 2 numbers and second 2 numbers in 4 numbers are equal, then also we call it proportion. Even this concept can be extended for some more numbers, say A, B, C, D. If these 2 ratios are equal, then fifth, suppose you take E and F, the fifth and sixth number, if that ratio is also equal, then also we can call all these 6 numbers are in proportion. Okay, and these are the types of proportion. We can say direct and inverse. So when 2 quantities are related with each other, they are in proportion, either direct or inverse, subject to either their ratio should be constant or their product should be constant. In vice versa, if I tell you that suppose these 2 quantities are in direct proportion, then its ratios are constant. Okay, so whenever there is a direct proportion, okay, what is constant? Their ratio is constant. And when there is an inverse proportion, their product is constant. Their product is constant. Now students, if you do not want to get confused, I can give you one smart tip that whenever there is a direct proportion, what do we do in ratio? In ratio we do division. Okay, you can remember the division D. D for division, D for direct. So when there is a direct proportion, D, divide. Okay, you divide that 2 numbers, 2 quantities. When you divide, you get ratio. Okay, and when there is inverse variation, that product is constant. What do we mean by product? Product, the another we call as into. Okay, product of 4 and 5. Product of say 4 and 5. What do we call? 4 into 5. So product means into, and when there is an inverse variation I, you multiply, means you into. Into means product. So this is the simple clue to remember that if there is a direct proportion, what is constant? D for division, division ratio. And inverse proportion I means into, starting with I, means product, multiplication is constant. Okay, we will solve some questions based on this in the next video. Thank you very much for watching this. If you like this video, please give me your likes. Your comments are welcome. If you are not yet subscribed to the channel, please subscribe and do not forget to press the bell icon. So whenever I will upload the new videos, you will get its notifications. Thank you and keep watching.